Hello everyone, I welcome you all to this next video in the Spring Framework lecture series. In the previous video, we learned the concept of dependency injection and inversion of control. These are the basic concepts governing Spring Framework. We also learned how beans are internally represented as dependency graph. A quick recap: the dependency graph is nothing but a directed graph where nodes are beans and edges represent dependencies of beans towards each other. In today's video, we will learn number 1, configuration of beans and dependencies, number 2, Spring Framework modules, number 3, Spring's application context. So without wasting any more time, let us get started. If you haven't already, please subscribe to the channel, like the video, and share the content as much as possible. First, let us understand configuration. In this example, the default communicator class needs access to the email sender object. Spring acts as an external system which reads class definitions, figure out the interdependencies between beans, construct the dependency graph, instantiate objects, and inject those objects into collaborative beans. To make all of this possible, there must be some kind of metadata associated with each bean. This metadata represents how we as application developers tell the Spring to instantiate, configure, and assemble beans of our application. This metadata is known as application configuration metadata. The fundamental purpose of configuration metadata is to declare bean definitions. Bean definitions are the blueprint Spring uses to instantiate beans and construct a cohesive application. The configuration metadata must include at the bare minimum the implementing class, bean ID, dependencies this bean depends on, and bean scope. The input to the IOC container is a beans configuration metadata and output is a fully configured system ready to use. The configuration metadata can be supplied in two ways. Number 1, using XML. Number 2, using Java classes. First, let us understand XML configuration. XML-based configuration metadata configure beans as bean element inside top-level beans element. The basic structure of XML-based configuration metadata looks like this. The beans and bean elements are highlighted for reference. ID can be any string which is used to uniquely identify a bean. Class is the implementing class for the bean. Scope specifies the bean scope. Scope is optional and the default bean scope is singleton, meaning only one bean object is instantiated per application. We will learn more about bean scope in the next video. Beans can specify dependencies on other beans using the property and ref elements. Property element is used to select a class property. Ref element is used to reference other beans from the Spring configuration metadata. Let us understand how to use property and ref elements with the help of an example. First, I am defining the email sender bean, choosing an appropriate ID. Class is the implementation class, which is default email sender in this case, leaving the scope empty. That should default it to singleton. Second, I am defining the communicator bean, choosing an appropriate ID. Class is the implementation class, which is default communicator in this case, leaving the scope empty. That should default it to singleton. Now importantly, the communicator need access to email sender bean. If you recall, default communicator has a class property email sender which is of type email sender. I am using the property element here to select the class property. Ref element is used to reference other elements in the configuration metadata with the help of bean ID. I am using email sender as the bean ID to reference email sender bean. Next, let us understand Java-based configuration. The primary building blocks of the Java configuration are configuration annotated classes and bean annotated methods. Configuration classes provide the source of bean definitions, and a bean method is the actual bean definition. There can be multiple configuration classes, and Spring scan all such classes to find bean definitions. Bean methods are used to indicate that a method instantiates and configures a new object to be managed by the Spring IOC container. One important feature of configuration classes is that they let us define inter-bean dependencies by calling other bean methods in the same class. As the communicator bean depends on email sender bean, we can call the email sender method to get the bean object. In practicality, Spring intercepts these calls, and if a cached instance is available, return us the cached object. If no cached instance is available, it will invoke the email sender method and cache the returning object. Bean method can express dependencies on other method with the help of method arguments. Instead of calling the email sender method, we can also express dependency by specifying it as a method argument. The bean annotation plays the same role as bean XML element. The ID of the bean is the method name, and the implementing class is deduced from the method return type. Let me explain how it works. Spring IOC container scan through the configuration class for bean methods. Spring uses Java reflection to pass details like return type, method arguments, method name, etc. Whenever Spring wants to instantiate an object for the bean definition, Spring would invoke the method and use the return type object as the bean object. The lifecycle of objects written by the bean method is managed by the Spring IOC container, and they can be injected anywhere in the application. Two important points to remember regarding configuration classes and bean methods. Number 1. It is not mandatory for a bean method to be present only in configuration class. Bean methods can be present in standard bean classes as well. The only difference between the two is that unlike configuration class, internal method call to other bean methods are not intercepted by Spring, and every time such method is called, a new instance is always returned. Number 2. Configuration classes are internally treated as beans by the Spring IOC container. In the previous video, we learned why is there a need for the Spring framework. Now let us understand what is Spring framework. At the fundamental level, Spring is a dependency injection framework and inversion of control container. It was created by Rod Johnson, and the first production release was in 2004. Spring broadly consists of 7 well-structured modules which are shown here. We will learn about each one of them in detail, starting with the core module. The Spring core container is subdivided into 4 modules. These modules form the backbone of Spring core container and transitively the entire Spring ecosystem. Let us understand each one of them in brief. The first one is core module. Core module is the base for everything. Every other module depends on this core module, either directly or indirectly. The core module contains utility classes for class level metadata scanning, annotation processing, and Java reflection. The next one is Beans module. Spring Beans module forms the backbone of Beans ecosystem in Spring. The central point of contact in this module is Bean Factory interface. Bean Factory internally is a complex implementation of the standard factory pattern. Next one is Context module. Context module builds on the robust foundation provided by the core and Beans module. The primary contact point in this module is Application Context Interface, which builds on the groundwork laid by Bean Factory interface. The Beans module is what makes Spring a container, but it is this context module that makes Spring a framework. Application Context module extends the functionality of core container by adding support for number 1, internationalization, number 2, application lifecycle management including support for lifecycle events, number 3, validation, number 4, services such as email access, JNDI access, EJB integration, etc. Number 5, provides necessary support for integration with templating frameworks like Velocity or Thymeleaf. Lastly, we have a Spring Expression Language module. We learned about the object dependency graph and its usage in our previous sections. The Spring Expression Language is a powerful expression language that supports querying and manipulating an object graph at runtime. We learned in the previous section about configuration metadata. Now, if you are curious like me, two natural questions that should come to your mind is: number 1, who reads configuration? Number 2, how to access the Spring IOC container? In this next section, we will find out the answers to these questions. The Bean Factory is the root interface for accessing a Spring Bean container. Bean Factory is a central registry of application components, and implementations of this interface holds a number of Bean definitions. The APIs exposed by the Bean Factory allows us to get an instance of any bean identified by the string name. The application context is a sub-interface of the Bean Factory interface. Application context contains within itself all the functionalities provided by Bean Factory plus some additional functionalities that makes Spring a framework. Application context is the primary entry point to Spring IOC container for all common purposes like loading of configuration files, triggering a class path scan, programmatically registering bean definitions, or annotation processing. Application context is a sub-interface to Bean Factory. It contains within itself all of the functionalities of Bean Factory plus some additional functionalities, namely number 1, message resolution and internationalization support. Number 2, application-wide event publication to registered listeners. Number 3, annotation-based dependency injection. Number 4, support for integration with databases, ORMs, and is suitable for building web applications. An important note: you shouldn't work with Bean Factory directly. Instead, you should always work with application context. If we use Bean Factory directly, all of these features will be missing and they will not be activated by default. Unless otherwise stated, when I say Spring IOC container, I meant application context and not the Bean Factory. Application context is an interface, and multiple implementations of this interface may be classified into multiple types of application context. Let us understand in brief different types of application context. The first one is class path XML application context. This is a variant of application context which loads configuration metadata from an XML file present in the class path. The argument to the constructor is the location of the XML file in class path. The next one we have is file system XML application context, a variant of the application context which loads configuration metadata from an XML file present anywhere in the file system. The argument to the constructor is the location of the XML file. Next, we have annotation config application context, a standalone application context that supports Java-based annotation configuration. The argument to the constructor is the root configuration class. Next, we have annotation config web application context. It is an extension of annotation config application context with support for web applications. At the end, we have XML web application context. An application context used in web applications that loads its configuration metadata from an XML file. By default, the configuration will be taken from webinf/applicationcontext.xml. Finally, let me talk about practical usage of application context. For a simple, standalone hobby application, it is okay to instantiate application context objects directly, but in any real-world production application, we hardly ever instantiate application context directly. Spring Framework has a sub-project, Spring Boot, which provides us with boilerplate code for instantiating and configuring Spring applications. Spring Boot instantiates application context based on the desired application type, and we never directly work with any particular implementation of application context. Instead, we always interact with application context interface APIs. We will learn more about Spring Boot in the upcoming lecture series. Comment your doubts in the comment section and I will address them as promptly as possible. The next video will be based on the Code with Me theme. In this video, we will implement a practical application using all the concepts learned so far. Once again, thank you and keep learning. I will see you in the next one.